Okay. Let's start by drawing the forces on the car. We've got a normal reaction force downwards and also the weight of the car. Those two will add to make the centripetal force. Now, it's saying this thing again where it's maintain contact, and that essentially means that it's in contact up until the reaction force here equals 0. So we're going to just take that limiting point there and say that the reaction force equals 0, and then that gives us mg equals mv squared over r. Cancel the masses, and it's quite simple then to work out the speed at the top of the loop. So I'm just going to plug that in now. That's going to be root gr, so that's 9.81 times 0.25, and then I take the square root, and that's 1.566 meters per second. Now they're asking for the speed that it must enter the loop. So I've now got to do a bit of energy conservation. I'm just going to remove this bit here, and if we look at the height that the car has moved upwards through, that's 0.5 meters. So we've got this kinetic energy at the bottom and the kinetic energy at the top. I'm going to call this 0, and I'm going to call this one 1. So we're going to say that the kinetic energy at the bottom is converted into the kinetic energy at the top plus the gravitational energy that we needed to put in. The height is 0.5 meters, so I've got a half v0 squared, which is the velocity that I want to find out. That's going to be a half v1 squared, which is this thing. So that's v1 plus mgh. Once again, I think we're cancelling the masses. And I'm going to multiply everything by 2, so that's going to give me 2gh. So all in all, I get v0, just change the color back, so v0 squared equals v1 squared plus 2gh. And then I'm just going to remove the square root as well. So that gives me that v0 equals the square root of v1 squared plus 2gh. So I take my velocity here, I square that, add 2 times gravity times the height, which was 0.5. Take the square root again, and I get 3.50 meters per second.